will show you now how to solve a problem involving inequalities and absolute values. That's something that the students learn in Algebra 2 pre-calculus, but they still make mistakes even though they already know the properties and the rules they have to follow to solve problems like this. And I also want to emphasize on the connection between the way to solve this algebraically and how to think of this problem as a functions, as a problem involving functions, because this is what they will continue using, applying in calculus and beyond. So let's go to this problem. We want to solve this inequality over here, which means that we want to find all the real values x that satisfy this inequality, which can be rewritten as the absolute value of x minus 2 greater than 1. You know that every time that you have an absolute value of something greater than a given number, that means that both the positive value what you have inside minus what you have inside must be greater than 1. So the problem can be split in two parts. The first part is the absolute value of x minus 2 greater than 1, or minus the absolute value of x minus 2 greater than 1. And that can be rewritten as x minus 2 greater than 3 or x minus 2 less than 1. We're talking about an OR. That means a union. That means that if the x value that you found satisfies the second condition, is okay. This is satisfying the first condition, is okay as well. So this is the union of two separate intervals. That happens because it's the absolute value of something greater than a given real number, a positive real number. Now, you have now two new inequalities. If you look at the first one, is again the absolute value of something, in this case x minus 2 is greater than 3. So you can split this in two parts, x minus 2 greater than 3 or minus x minus 2 greater than 3. Again, this is the absolute value of something greater than a given number. This is the union of two separate intervals. The first one is x greater than 5, the second one is s less than negative 1. So you have a union of two intervals, of two inequalities, and you know the solution of those two inequalities. Let's take a look at the second part of the original inequality, that is x minus 2 less than 1. Now you have a less than 1. If you apply exactly what you did before, in this case you have the intersection of two solutions. So only the x value that satisfy both conditions at the same time are the solution of this inequality, this smaller inequality. So the first one is x minus 2 less than 1, which means x less than 3. The second one is minus x minus 2 less than 1, that is x greater than 1. And this is the intersection of two inequalities. So the solution is the intersection of the solution of these two inequalities. So if you summarize, you have four conditions: the union of the first two, the intersection of the last two conditions, and then the union of the two results. So let's write it here. X greater than 5, x less than negative 1. This is a union, so both intervals are part of the solution. X less than 3 and excluding 1 and 3 because those are open intervals because you have originally greater than 1, less than 0. But remember that you have a union here. That means a union of these two solutions. That means all the real values in these intervals will be the solution of our problem. So any number less than -1, any number between 1 and 3, excluding 1 and 3, and any number greater than 5. Okay, now let's think about this problem, but from the perspective of a function, we want to find the x values for which y, which is the function, is greater than 0. So to solve this problem, if you look at this inequality carefully, you may identify a sequence of transformations starting from the absolute value of x. So this is what I mean. You have the absolute value of x, you already know the graph of this function, and you can see here that there is a first transformation, which is the absolute value of x minus 2, and you know that this is a horizontal shift. So the graph is shifted 2 units to the right. Then you have a second transformation, which is a vertical shift. So the graph of the absolute value of x minus 2 is shifted 2 units downward. The next step is to take the absolute value of this. That means that any part of the graph that is below the x-axis, that means that y is negative, now becomes positive. It's like a reflection across the x-axis. So everything that was negative now becomes positive. So we are almost there. There's one more step. It is another shift, a vertical shift. This shift in 1 unit downward. So if you look at this line, 1, basically you are shifting the whole graph 1 unit downward. So it goes to -1, for is the set of all possible real values x for which this function is positive. That means that the graph is above the x-axis. That means the y is positive. So the solution is the union of three intervals. That's what you observe here in the graph. Now, just compare what we obtain from the graph of the function and what you obtain when you solve this inequality with absolute values algebraically. This is the same. So, this is important for you to know that this connection, you are doing exactly the same in both cases, but it's important to identify the similarities between these approaches and the differences so you can apply it to more complex problems in the future involving other type of functions, and you will see that in calculus and other classes beyond. So I hope you have learned something. Thank you.